Hello students. So today we will see one theorem, and I have written the theorem over here. So let us read it. Let x be a rational number. So let x be a kind of a rational number whose decimal expansion terminates. That means x is a rational number that's also terminating type. The decimal expansion terminates. Then x can be expressed in the form of p upon q. Obviously, since this is rational number, so they can be expressed in the form of p upon q, where p and q are co-prime. We have seen it in the previous lecture, where p and q are co-prime, and the prime factorization of q. Now the point that you need to understand right now is this line, the prime factorization of q. Q means the denominator. The prime factorization of q, yani that means if you find out the LCM and all, you will see that they are of the form 2 to the power m, 5 to the power n, where m and n are integers. That means what? It means that if you need to have a kind of what? Terminating decimal expansion. This is the criteria, and the criteria is like, if you need to have a terminating decimal expansion, then the denominator must be of the form 2 to the power m into 5 to the power n. What does this 2 to the power m, 5 to the power n means? That means if you solve q in terms of prime factorization of q, you will find out all the factors which q is having are either in 2's or 5's or combination of both. Again I am saying that when you find out the LCM of q, that means you are finding doing what? The prime factorization of q. You will find out the factors of q which are coming. All the factors are either only 2's. How many 2's are there? I don't know. So that means we should not be bothered about them. There can be 1 2's, 2 2's, 3 2's, 4 2's. How many 2's are there? We don't know. So we are saying let m 2's be there. M number of 2's. So they can be either in 2's or they can be in 5's. That means 5, 5, 5, 5. You are finding out 5 only. So how many 5's are there? N number of 5's. So why we are writing down m and n? To show that how many 2's are there, you should not be bothered about. How many 5's are there, you should not be bothered about. One point that both must be same, that is also not there. So that's why we have taken two separate variables, m and n, in order to show that number of 2's and number of 5's can be different. Are you getting my point or not? So they can be either on 2's, that means no 5's, that is n can be 0. They can be either in 5's, that means all 5, m is 0, no 2's, or mixture of both, 2 and 5. Say 1 2 is there and 3 5's are there, like that. The point is that the denominator will be having factors in the form of 2 or 5 or 2 and 5 both. That's all. This is the criteria, and m and n are integers. Getting my point? So this is how you can say it is the criteria for having decimal expansion. Now if I want to have the decimal expansion does not terminate. So if does not terminate, then what will happen? If it is does not terminate, then they cannot be expressed in the form of 2 to the power m into 5 to the power m. That means if you find out any single other factor is there apart from 2 and 5, if you are able to find out any other third factor except 1, since 1 is the factor of each and every number, so never consider 1. So you forget about 1, and we are talking about prime factorization. So prime factors we are talking about, 1 is not a prime number. So based on that I can say that if any other prime number you are able to obtain, any other third prime number, you will immediately say that this will not be having terminating decimal expansion. Are you getting the point or not? So if it's not having terminating decimal expansion, then that means what? It can be either repeating or non-repeating type. Now the point is, non-repeating type of decimal expansion is an irrational form. So that means if it is not expressed, if you want whose decimal expansion does not terminate, if I put this doesn't terminate, if I put this word, then what will happen? Then is not of the form, then this will become not of the form 2 to the power and 5 to the power. Are you getting my point or not? So if does not terminate, and if it is a rational, then you will say this will correspond to what? Non-terminating and repeating type decimal expansion. So this will become repeating. Why we are not using non-repeating? Why we are not taking it? Because non-repeating type is never a rational number. Non-repeating type is always an irrational number. We have seen it in the first lecture. So that means non-repeating type we will not be taking. So we will be taking repeating type. This thing you have done in your previous class, class 9. Remember the questions of bar, and you need to convert them to rational form. Say 3.6 bar, convert it to the form of P upon Q, or convert it to a rational number. You used to do what? The ways you used to solve the questions. Ultimately, you used to get some rational form. But that is what we have done it in our previous class. So that's what we are saying. That if it is non-terminating, then definitely, if it is rational number, then definitely it will be a repeating type decimal expansion. Clear? Please note. So based on this, if I look onto the questions of exercise 1.4, the exercise is extremely simple. You can do it right now only. The first question, each and every question you need to do what? Say 11 upon 3125. First, before doing the question, you first understand what the question is asking from you. That without actually performing the long division, you will not perform the long division. Apart from doing the long division, state whether the following rational numbers will have a terminating decimal expansion or non-terminating decimal expansion. They are just asking you about terminating and non-terminating decimal expansion. So based on this, I can say if it is 11 upon 3125, first you use the criteria of this. That whether this is in rational form, yes, this is a rational form. Okay. Is it expressed in the form of P upon Q? Yes, it is. Are P and Q co-prime? That means you need to see whether it is in lowest form or not. That's the standard form of rational number. If any other factor is there of both the numbers, then you will cancel them out and you will convert them to lowest form. So before converting to lowest form, you will not do any other thing. So first you try to see whether this can be converted to lowest form. So see whether this is divisible by 11 or not. So as I can see, no, it's not divisible by 11. So based on this, now if they are co-prime, then do the prime factorization. The prime factorization of 3125. So find out LCM of 3125. So 56, 52, 51, then this is 5. So 3125 can be written as 5 to the power 5. Now you will write down the statement, since denominator is expressed in the form of 2 to the power m into 5 to the power m. That means you can write it down as 2 to the power 0 if you want. Okay, it can be represented as 2 to the power m into 5 to the power m, where m and n are integers. So therefore, yes, it has terminating decimal expansion. But if you find out any other third factor is there, apart from we are getting only 5, there can be questions where you are getting only 2's. There are questions where you are getting mixture of 5 and 2's. So all of them are acceptable. Only those cases wherein you find out any other third number is coming, you will simply say no, it is not. But before doing the prime factorization, let me remind you again and again, first convert it into standard form, that is lowest form. Without converting them to standard form, this should not be done. For example, if I take a question like this, say I am taking 15 upon this is 21. Now if a student goes to solve this question, he will simply say 15, okay, 15 is having 5 into 3, so 3 is coming. He will say no, it's not a terminating decimal expansion. But this will go wrong. Why? Because when you convert it into standard form, you will convert with a divide by 3, 3 5s are 15, 3 7s are 21, 7 upon 5. Now you see whether it is terminating or not. Yes, it is terminating. It is having 5 only in the denominator. So this shows what? Ki the number was a terminating type. But instead of converting into standard form, you directly did what? The grand factorization of the denominator, and you came to the conclusion that no, it is not a terminating decimal expansion. So the answer will go wrong. So first convert it to standard form and then you try to find out the answer. Got it? In question number 2, as you can see in question number 2, they are saying that for all those questions given in question number 1, the ones which are having terminating decimal expansion, terminating type, convert them to their decimal form. So you'll do what? You will do the division. You do the division and you find out. Normally these kind of question we did it in our previous classes. CBSE also, it never gives this kind of a question because this looks very silly on the part of a class 10 student. But yes, this is something which is given in the NCERT. So initially you all must do it once in order to see whether you are able to divide it properly or not, because even if we move on to our higher classes, there are still few basic concepts in which we lack precision or in which we lack practice. So sometimes division is also a criteria which I have seen that most of the students of very higher classes, they also find out difficulty in doing that for non-divisions. So you try to do this. So here you will do what? You will divide 11 by 3125 and you try to find out the answer. Clear? In decimal form. That is question number 2. And for question number 3, just by looking onto the question, you need to say that whether it is means what type of rational number. So look on to question number 3, first part. The number has ended. After decimal places, the number has terminated. It's finite. So you will say this is what? Terminating type decimal expansion. The first one. The second one, as you can see that the numbers are not repeated. So this is non-terminating because dot 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 is there. So that means this is continued indefinitely. So that means this is non-terminating as well as non-repeating. The second one. And the third one is having bar, that means this is repeating. So repeating is again a type of rational number. So means what kind of rational number? Terminating, repeating type. Non-terminating, repeating type. So the first one I am just writing down one by one. Question number 3, first part, that is terminating type. Second one, non-terminating and non-repeating. And the third one, non-terminating and repeating. This is a decimal expansion. Now they are asking whether they are rational number or not. So you will say yes, they are rational. They are rational. यहाँ पे no, they are not rational, and yes, they are rational. So this is all about the exercise. Please pause the video to note it down.